Counter bore are enlarged pre-elaborating holes and commonly used to hide that the head of the socket head screw. Does that make sense? Counter bore is just enlarged pre-elaborating holes. Is that right? That's what we use to set flat head screws. Counter bore to hide the head of the socket head screw. This part is called a coupling. They have 3 tap holes, equally spaced. How much is the angularity in between them?
3 divided by 4, like
120.
120, yeah.
How do you achieve that? How do you find that?
360
Divided by 20. If I have 4 holes, that would be what?
360 divided by 4.
90.
Is that right? Excellent, excellent. This area of the coupling that is enlarged from the diameter, that's commonly said to set clearance hole, is called what? This area of the coupling that is commonly sent to clearance holes is called what?
A flange.
A flange. Is that right? The center hole is called what?
Bore.
Bore hole. Is that right? Counter bore hole. Is that right? I don't know if you read the page 41, but clearance holes is with the intention to set screw that goes through, and the amount of clearance is amount around what? The amount of clearance, the hole had to be larger than the screw. How much large?
30,000.
31,000. Yes, 31,000. Yeah, 31,000. Not every hole requires clearance. A hole that requires no clearance or very small clearance, that's for the whole pin. But commonly for a set screw to put part together, it's called clearance hole is 31,000. On a coupling, that area or any part that go up and down around the shaft is called what? Hub. Does that make sense? That's the hub. Diameter of the hub in this part, inch and 200, for example. In the middle, we have something that we call keyway. When the keyway is a regular groove, it's dimensioned by width and depth. When the keyway happens on a shaft, it's called keyseat. For example, right there, we have a keyseat. Is that right? And this is a keyway. Keyway is on a moving part that we want to restrict the move. Keyseat is on the shaft. I want you to go on your book. I think to go in your book on page 131. I want you guys read when they say keyseat and keyway. They don't sign and put you here yet, so your last name, I remember, I know Diego Valdez. I'm gonna need you to sign right here. All right. Everybody, please. Okay, well, we're getting conclusion from them. So first of all, what they put a key, where is the key C cut? Key C is cut on the shaft, right? Yes or no? And let's see, on the hub, or in the gear, or even in a worm, they have the keyway. Is that right? They both, if they want to work together, they need to have the same dimensions. Dimension like a regular groove. First, they use a little line. First is the width. How much is the width? Well, for this one, 250,000. All right. Second one, like you doing a regular groove before. If this is a regular groove, dimension is always first come with and then with that. All right. In that, how much is the key C? 250,000. All right. Look at every color have the key C right there. Is that right? The key C is right here. The key is inside it. The other one is inside the spindle. But if you look at right here, this part, that's the key C right there. See it? How much is that key C? I don't know. Well, they tell me right there it's 250,000. So we use a tool bit. You can do with an M mill. The problem when you do with the M mill cut size, it can be wider. And then when you put the key and they start working, they start moving, or they should hear sound, or they are not working properly. Because when they create impact between two materials, they start producing temperature. The temperature makes them soft, and the soft making them warm, open, warm. So this one is the cutter. So this one is perfectly ground on the side. They don't cut by the side. They only cut by the front or teeth. So you touch the part, you get half of that, and you cut them, plain cut them CNC. If it's unconventional, then you gotta do, if it's unconventional, then you gotta do conventional cuts. Does that make sense? So this is the key cutter, key C cutter. Is that right? First, the width of this one is the same to that one. No doubt it. Half of the part, half of the width, move down, boom, got it. Does that make sense? All right. Key C cutter. When we want to cut on a key, we use a broach. Broach is a tool and you build machine from the metal. There is a broach. Probably you saw it before. The broach is a tool with multiple tools that they have an increment like a saw, but they have an incremental. It's a straight tool, and they have an incremental of probably 1,000 or 2,000 in every tooth to the end. If I want to end in 200,000, my first cut, I start by the diameter of the part, and then I cut the first pass probably 1/2,000, and the other tooth cut another 1/2,000, and probably need 50 tooth to cut all the way through. Does that make sense? Because every tooth the cut, or you have the tooth at the beginning cut more, at the end almost nothing. But they call it broach. It goes inside. Wow! Make keyway. All right? Keyways. But they are both dimension, and there is this type of key. That one is called Woodruff. This one, the tool is positioned into specific positions, and then boom, they cut it apart. As you can see in your book right there. The Woodruff come, this one, if you notice, they come with the number. They don't specify how much is the width or how much is the depth. They don't tell you. That's why I give you a chart, right? But if you don't have that chart, you have a formula to calculate them. The last two digits, you multiply for 1/8, the first two digits for 1/3 seconds, but you probably forgot that part. I want you to put right here, go to see page number, let me see, 3, dictionary terms. Let me tell you what page. You have to go to see. Page 5. You put right there, see page 5 on your book. All right? So, on the page 5, think, what is your name? I forgot your name already.
Richard?
Richard, hey guys, now I remember because I was trying to remember your name on Friday, on Thursday, because we had to turn the parallels. The parallels that you cut, we gotta put it on the box to send it to heat treat. Is that right? I was looking at your toolbox, but I didn't find it. I don't find none of your toolbox. Where do you put them? Maybe you take home, it's okay, you take it home. But if it's, I was looking for, you put it in a cabinet?
I approve with them.
In my phone, in your cabinet?
In Mark 3.
In Mark 3. Okay, so yeah. So we gotta take the parallels, send it to heat treat. I remember now. Don't let me forget that part. As soon as we get to the shop, let's go do that. Okay? So here, the last two digits give you diameter. Diameter is equal to 10 and multiply and what? And 1/8, right? Yes or no? That would be 10/8. That is equal to what? To 1 1/4. Yes or no? Huh? 1 1/4, right?
Mm-hmm.
So 1 1/4 is the diameter of the tool bit that I need to cut this one. Or if you don't have the number, but the tool bit comes with the number right there. This one, right there. See the number right there? This one is A07. What happened with they had 3 numbers? Is the last digit. Is that right? So you multiply times 1/8. So that tell you the tool bit that you have to use for this one. It will be diameter. How much is diameter? 1. How much is diameter? 1 1/4. The preceding digit, how many digits are preceding here? 1 or 2? After the last 2? 2. What is the number? 12. 12 times what? Times 1/32. You don't find that in your book? It's on page 5 at the end. Look at page 5, the last paragraph. Put it right here. See page number 5. For diameter and thickness. Is that right? So 12/32. How much is 12/32, guys? So 3/8. How much is 3/8? 375. The thickness of that tool that you want to use it when you cut is 375. Everything is in that. On a dictionary term, you pay 5 at the end of the page. Page 5 at the end of the page. Page 5 at the end of the page. Right there. See it? Read it and highlight it, guys. Read it and highlight that. Make an asterisk, that way you remember. That is important for you to remember, because you as machinists might need to go ahead and sometimes you don't have the right tools. What about if I don't have the right tool? I found the right tool in diameter, but I don't have the thickness. What I can do it? I can set that right there in the surface grinder and grind the thickness to the specific size. Don't forget always to put a clearance right here. Because this one you can reduce on a grinder. Because grinders are cut heat treat part. Does that make sense? But yeah, or you don't see the number, you can check by diameter. See those 3 numbers in a good rough, easy cutter, are implicit in this code that you have right there. The last two digits multiplied times 1/8, it gives you what? Read in the book. Can you read that cloud right there? The diameter. And the preceding digit, if it's 1, if it's 2, if it's 3, multiply times 1/32, it gives you what, Louis? And Diego will give you what? So basically, I want you to go to page number 5, Diego.
Is that a way?
The width, the thickness. We call thickness. Is that right? It's the width of the groove. Yeah. Or the width of the groove. Yeah. Will you read that part? Will you read that part loud? Page 5, Diego. At the end, read it. Diego is the one sleeping. I'm waking up right now. I don't want to make him push-ups because I don't want to be too tough. We're not in the military anymore.
Key cuts multiple two basic dimensions. Diameter and width are coded into the key number. The last two digits designate the diameter in 1/8 of an inch. The preceding digits designate with 1 and 1/32 of an inch.
Is that right? Beautiful. All right? This information is a machinist handbook, but you need to know that. You know what I'm saying? You need to know that part. Okay, guys. We finished with the first part of this one. Now we're going to move quickly to what page we're going to move. Okay. We're going to move quickly. Did you read during the weekend, during the 3 days? Probably not. Is that right? Yeah, because we have things to do. And then your wife wants you to watch a movie. And if you don't watch a movie, then you're a mean guy. That happened to me too. But I get up in the morning and then I read it when everybody's sleeping. Because if not, they start bothering me all the time. So I like that part. But, okay. What we're going to do now? Quickly. What is a fillet? No problem. Let me start from this part. Do you know what is a casting part? Huh? Do you know how to make the casting? You probably say, I have an idea, but I want to see what it is. Well, that's it. I don't have internet here. I didn't, huh? I want to show you a quick video how they make art by casting, okay? Because has anybody been in a foundry before? No? Hey guys, you don't like to talk in the morning?
portable CNC milling machine featuring the power and rigidity to remove 30 pounds of steel per hour with the accuracy and precision to hold tight tolerances.
What is that blue thing on my, and you guys know it? Why? Somebody saw that. Son of the gun. All right, guys. Can you turn the light, please? All right. Look at casting that have been used when you want to make a part that have a complex shape. Is that right? And the complex shape, and we got thin walls. Is you can make this from a block of steel, but it'll take a lot of time to cut all this material. Does that make sense? So what we do, we make using the physical property of material. When this is exposed to temperature, 2000 Fahrenheit, they melt it, they get the liquid stage. We forming a mold with the pattern, and that mold, it can be made on sand, on other materials, is that right? Commonly, the most popular is the sand. They use a special type of sand. Not the regular that we see in the beach. It's called green sand. And that one, with that, we create an imprint on the box around using that sand, and then you go half and the other half in two boxes. In both, we create the hole or the cavity with the pattern, and then you put them together and you create a couple holes, fitting holes. All right.
Then this is Angel, and then this is Ben.
This is Angel. All right, cool. All right. Good to see you, Kim. Good to see you, Angel. So we create a pattern, is that right? And in that pattern, it'll with, you put it together and they put two holes and the metal will pour inside there. Does that make sense? And that we produce casting. The problem with casting is it's hard to create square corners. So on a casting, when they talk about square corner, we create something that we call a fillet. This is a fillet. Does that make sense? And also, we create this to create rigidity. And every time you see a part of casting, you will see this line right there. And people thought this line because they put the part together. No. This line because the bars are together. And this is solid material, but they leak a little bit from there. The problem with casting the surface is very rough, so we need to finish the surface. So we need to cut the surface. In order to cut the surface, the casting has to be large. The part when it's cast has to be large. We need extra materials on the part, that way when we cut it, we obtain the clean surface. This allowance is 120,000 as you read in the book, but called finish allowance. Is that right? The whole is called whole clearance. This one is finish allowance. The allowance I did in the holes is whole clearance. They don't call allowance, they call whole clearance. But in this one called finish allowance. It's 120,000. But if it's inside surface, it will be minus 120,000. Is that right? So if this one is 1 inch, I have to cut in this one 670. That way with my boarding part, I have 120,000 from here to cut the part. Does that make sense? Yeah. On the casting part, you will see quickly what the surface will be machined if the part is machined. But before machining, you don't know which is machining. So you have to look at the print. And in the print, they will show you which one will be machine surface. For example, on a print, you will see these symbols right here. Those symbols right here representing the finished surface. Every time you see any of those symbols, that means that surface need to be large, 120,000 minimum, before you cut the part. On a print, they tell you exactly what is the size. It's you that when you buy the stock, you have to check it. Because they give you the print. If the part is 3 inch high, how much the part should be before machining. 3 inch plus 120, 3 inch plus 120, that will be 3 inch and 240. Yes or no? Minimum. But if it's in this surface, from here to here, the part should be high in that surface. If it's 3 inch, that would be 3 inch and 120. And if it's in the board, it will be minus 20,000 per size, so that would be minus 240. You guys understand that part? Right? Those are finish allowance. It's in the book. Finish symbols. You can, this one, they are hot the whole meeting. In your print, you will see this. Because in a print, you cannot identify what surface is machined. But in here, you can see it. That one is machined, but that one not. In the print, you identify by that. Does that make sense? We're talking about finish allowance. I refer, it's 1A. You see the phantom line right here? In some print, they show you the stack size. If you do master can, they give you stack size. The stack size is larger than the part commonly. You have to machine that surface. How much? 120,000 on the casting. Casting requires more allowance than other surface. Why? Because sometimes they have deformation because the temperature is position, or they have porosity, or very rough surface. They require to be machined more. So they use phantom line to tell you this is the part before machining. They don't tell you, sometimes, they don't give you phantom line, but they give you that symbol. It's 1A. 1A is round, two decimal places. In your blueprint, it's 120. And the tolerance is 120. This is called what? Finish allowance. This is in your page 141. Does that make sense? In the page 141, you also read that this one is called a fillet. I show you what is a fillet. A fillet is the joint between two surfaces like this one right there. And the outside part is also called a round. Does that make sense? Fillet and rounds. Yes. In the page 141 or 42, you got clearance holes. What are clearance holes? The one that we use to set on the part to put them together. Clearance holes for bolts. Determine how critical is the alignments. The obtain require extremely accuracy using light or no clearance, bolt, rivets, have clearance to assembly. Yes. How much is the clearance for clearance holes? In what page is that one? I think clearance holes is on page 142, right? 141. If I want to put a screw right here, right there, I need a clearance that has to be 31 thousandths. Does that make sense? 1732nd hole is required to set half-inch screws on a part. Does that make sense? All right. Well. Half view. I'm just reviewing what you read. Half view is when on a print the part in one of the view doesn't show completely because the part is symmetrical. Those two lines, it doesn't mean lieutenant. That means that is symmetrical. Is that right? Symmetrical above the y-axis. Same that you see here, you will see it right there. Is that right? This one is called a half view. That's my front view. In the right side, what type of view I have? Half view. How many holes is in that part? 4. I only see 3 because it's a half view. Because the part is symmetrical. And then you got the part. But I promise I want to show you this. And you're anxious to see that video, yes or no? Okay, I've been sleeping in the foundries, believe me. Yes, I sleep here in the back right there. It was a foundry. Man, so hot. I gotta put a fan to pull all the smoke out. I sleep with that thing. Horrible. What is this? Diego, what do you think is that? It's making on wood. And we want to make a wood part? No, we want to make an aluminum part. We want to cast in that part. This one right here, what is that? Luis, what is that? You don't know? Well, look it. If I want to cast in this part, the mold maker made that part. This is the pattern. What do you want to do with this pattern? Huh? You want to see it? Take a look. Why they make it in 2 pieces? Because they want to create complete whole cavity. So they cast in half and half. Then they remove it, they put it together, they have a cavity inside. They pour the metals and you will see the part. They make it nice, shiny, and smooth. Why? To obtain better surface. Because even though it's nice and shiny and smooth, there is an oxidation happen outside the part and that produces all those bubbles. Like you see right there. Those is when they sand shape and that the molds are made that no matter what. Check this out. This is the pattern of the part. Same way they do it here, they do it in production. This guy work at home. This part right here is called a core. Remember that word, core. If I want to cast in this piston, do you want all these cavities? You have to create a core. Core goes inside. They use the same sand, but they put a gluten that maintain them more together when they put it inside. Why they make it on sand? Because this one has to be destroyed to pull it out from the part. Because when they cast it, all this will be trapped inside the casting. It's like how you make What is it? A walnut chocolate or Ferrero Rocher that they create something and they have to make it all up, put that in out. Yeah. Yeah. Or M&M, Shields, and it's like, no. Chocolate. Cheese. Or chile relleno. This is what the monies are. If you make this, you make money. Because that has to be precise. And every surface with the machine has to be large in how much? Luis? There you go. That's why you made the big box. How much has to be?
Is it 31?
120,000. 31,000 is the clearance holes. The finish allowance, we call that the casting enlarged from the surface that will be cut. 120,000. Remember that part. That's the cord that goes inside the casting part. See, the part looks like that inside. Look at what he did. They use a special sand they call green sand. They pack completely. See? Baby powder. Look you guys. What you gotta do now? See? You wanna make the other half. So you put the other half together. So, I want to put, see this right here? They have a dowel pin right here in that corner. Understand? What is dowel pin are made for? To make sure the casting pieces get exactly in the same position. Now he's going to cut the ingots that the metal goes in. Now that it's cut, he wants to remove the pack. You gotta be careful because you know what happened. See, I want you to notice right here, all these area on the corners are round. And how do we call this? Fillet. And the other one on side is called what? Rounds. You see a note on the print, fillets are round, 100,000. Boom, right there. That's the cavity. That will be fulfilled with what? Aluminum. Is that right? But are we gonna make a solid part or a hollow part? Hollow part. If we wanna make a hollow part, what do we have to put inside? A core. Beautiful. He took a couple of vents to breathe. The gases come out because the temperature. This right here is called what? Core. All these will be destroyed. You're gonna make one of these for each part. And then all will be destroyed. Now the other half. Is that right? See, what he's doing now, he got setting the alignments. Because you know they are not together. That's what the line that you see it. Because that. Now he prepared what is called the feeder head. The other one probably called the runner. Because metal, if the metal touches straight, the mold, it will destroy it. One and two. One is to go in and the other one is to come in out. To make sure everything is fulfilled inside. Now it's the cooking part. Now it's melting. The soup is ready. There you go. Notice right here, they come smart from here. It's hard to see it. See this mark? Huh? We wait 15 minutes only, and then now it's time to destroy everything. You don't have to, if you let that too long, that would be solid like a brick. What is that inside? What is this?
The core?
How much is the allowance on the walls of the court?
Is it
120.
120 per size. Does that make sense? How cylindrical fault is that positive allowance? Negative. 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 Minus 120. Minus 120, minus 120. Smaller than the surface, finished surface. Does that make sense? So you have to make it 120. So you see this mark right here? That's the joint between the two boxes. They leak a little bit. Sometimes they put heavy things on that, that way they don't feed too much clothes. That makes sense? Now this is your part right here. Second process here, this area is called a box. Box. When it's round, raising up on material, called a box. Box, box, box. If it's different than round, it's called a pad. Is that right? All right, guys. Now, look at. I don't know. We got 10 minutes. We're planning to be at tonight here. Well, we start at 8. 8, right? Tonight's 1 hour. And now, do you work in this piece right here, guys? Remember that part? I think you answered a couple questions from this part. I think somebody was talking about how do you answer, for example, question D. Do you answer your question D? Tell me about it. You didn't answer none of those. Does that make sense? No problem. That's not a big deal now. So I want you to go home today, and I want you to answer that print and the next print too, both of them. Because that is what I want to do tomorrow. Tomorrow we're going to review that print, that one that you have right there. Not this one, the one on page, let me see. Is it right? I want you to answer the first one before that one. More page. This one is 218021. 8021, right? 218021 completely for tomorrow. Is that right? You probably say, okay, I don't know how to do this. Let me know. I'm going to show you quickly how to answer D. Is that right? What is the dimension D? If you look at your part right here. Because you got to do this at home. Yes or no? Huh? This review is what we want to do. And it's hard to read this. Oh my God. What are your dimensions? What is the dimension D? Look at the arrowhead right here. And look at the arrowhead right here. If I move this up here and move this up here, the distance from what? What is this? This is the bold circle. What is this? This is the OD. Yes or no? On a flange. Yes or no? Huh? Is that true? Or it's a lie? Oh, I know accurate. Look at it. Those two are connecting. And this one? If you use a ruler on your pen, boom, boom. But you gotta make sure that those lines come perpendicular. So I went walking yesterday, I think it was a CVS, and I find this. On a CVS, you got those tools that you need. On the school part sections, school supplies. That you can, because in here, you don't have any dimension for the OD. So yes, D is equal to parentheses, outside diameter minus bold circle diameter, and then what? Divided by 2. Because every time I have a call out or dimension that is from one side to center line, I have to divide it by 2. How much is the OD of this part? How much is the OD of this part?
4 inch 800.
4 inch and 800. And how much is the tolerance?
Is it 3,600? 3 into
2
600?
decimal places plus minus 10,000. Yes or no?
Yeah.
How much is the bold circles? 3 inch and 600. Yes. And how much is the tolerance of the bold circle?
Plus or minus 5,000.
Plus or minus 5,000. Boom, I enclose that between parentheses and I divide it by 2. Yes or not? Alright? I go 1 inch and 4 inch and 800 minus 360 is 120. Yes or no? 1 inch and 200. 1 inch and 200. And how much is the tolerance now? 10 and 5 plus minus what? 15,000. Do I have to divide this by 2? Yes, because no, I have 2 and I want only 1. Remember, Mike Tyson only buy 1 ear of, I don't know, what is the guy said? Holyfields, whatever? Yeah, only 1 ear, not 2. So, but we had to divide by 2. Ivan Holyfields? Yes. So that would be what? 600. 600 plus minus what? 7,000? I'm 510. Because I had to divide the tolerance too. I had to divide that, and I had to divide that. And that's exactly how D will be. Did you gentlemen understand that? Perfect, perfect, perfect. But you say, oh man, can you do C too? Okay. You want to try C? What about if I try C? You want me to try C? I will do it. Check this out. I have 2 minutes. 2 more minutes. 2 more minutes. I want to use a different color for C. C. Okay, what is C? Well, look at guys. It's right here. So I move to there, I move to there. I use my triangles. I put it right here. I move the triangle, and now I go from here up. I'll put the other one to the heating line, and I move up. Okay, it's just a wall thickness. Wall thickness. Is that right? So wall thickness is in your book. You do that on page 31. Because X is equal to capital D minus small d divided by 2. Page 31 in your book. You've been doing that since Math 1 on page 31. Right now, I want to just adapt this formula to these situations. This in here is what? A hub. Is that right? Hub what? Diameter. And this in here is what? Bore diameter. Therefore, C will be equal to hub diameter minus bore diameter, and then what? What do I have? Divided by 2. That's what everybody forgot. Divided by 2. All right? Buy the sandwich for you, divided by 2, give it half to your wife. Because you're supposed to fit there. Now, how much is the hub diameter? 2 inches. Plus minus what?
10,000.
10 thousandths. How much is the bore diameter?
1
Plus minus what?
5,000.
5 thousandths. Divided by 2. So that would be equal 700 plus minus 50,000 divided by 2. 700 divided by 2 is what? 350,000, not 35. 350,000 and 15 divided by 2 is what?
75,000.
7,000 and 510. Okay? Right. Ten. What do you think, guys? Are those examples clear for you? Diego? Mr. Bayou Lewis? Are those clear for you?
Clear.
So you think that tomorrow you wanna bring all those two planes completely answered from head to toe?
Yes, sir.
There you go, deal. So, no problem. If you didn't do it, what happened? Still pile up, pile up, pile up, pile up. And I want to be right there. I want to be sharp. Take it 5 seconds, 5 minutes. That's the time. After work, before work, as soon as you get up, before you go to bed, get this done. Okay? Those two. Wrong or right, make it happen. Think about it. Put some time in yourself. Okay? I know it's hard to wake up in the morning today. I put my clock at 5 o'clock, but I couldn't do it. But I realized that if I don't do it, I will suffer. I didn't have lunch, I didn't have breakfast, I had to come here quickly. No, that's no way to live. Next time, even though I'm tired, I go. But you know what is the hard thing that I say? Somebody asked me, Muhammad Ali, one time, what is the hard thing for you? Training so hard. And you know what he said? The hard time is go to bed 9 o'clock. That's the hard time. That's where you start. If I go to bed 9 o'clock, I get up early, start working out, do my exercise, do my training build up. If I don't go to bed at that time, what happens? The whole next day will be ruined. Not on just one time, the whole next day. So I've been all day trying to put it up, and it'll pile up. So that, the important thing is try to get you 8 hours sleep. Does that make sense? That is important. 8 hours, 6 hours, depending you need it. So people need less than that. Like they say Einstein only sleep like 3 to 4 hours. I don't have that brain. Does that make sense? Gentlemen, it's 9 o'clock. We're going to go to the shop right now. I want to go tomorrow. You finish everything? When you finish? Excellent. But who else finished?
I just got a question. What's the minimum keyway width?
Minimum keyword width.
Yeah.
Perfect. If you look at right here, that's the keyword width, right? Yes or no? You know, I want to review Diego before you leave. This is your width. How much is the width? How much is the width of the keyword? This is the keyword, right? Yes or no? I mean, do you know this is the keyword right here, right? Yes or no?
Oh, yeah.
Huh? Yes or no?
Yes.
How much is the